Welcome to Xerox Unstuck. Today contains duplicate. Does any value in an array appear more than once? It's a tiny problem that teaches one of the most useful tools in programming, the HashSet. We'll build it in Rust and go from on squared to on. The obvious solution compares every pair of elements. It works, but on a big array it's painfully slow. A HashSet does the same job in a single pass. Let's see both. If you find this clear, really helps. Let's start with the brute force. The first idea, compare every element with every element after it. If any two match, there's a duplicate. Simple, but the number of pairs grows with n squared. Here it is, a loop inside a loop, checking v at I against v at j, correct, and on squared. 30,000 elements with a duplicate at the very end, and it takes about 240 milliseconds, chewing through hundreds of millions of pairs. Every element is compared with every other one, so 30,000 items means hundreds of millions of comparisons. That's the n squared tax again. Enter the hash set. It's a collection that stores only unique values, and it can answer, have I seen this before? In roughly constant time. That's exactly the question we're asking. So, walk the array once, for each value, try to add it to the set. If it's already there, we found a duplicate. If we reached the end without that happening, every value was unique. And Rust makes this beautiful hash set. Since it returns a boolean, true if the value was new, false if it was already present. So if not seen dot insert of x literally reads as if we'd already seen x, return true. Run it, same 30,000 elements, 1.5 milliseconds, same answer, over 100 times faster. From on squared to on, the set uses some extra memory to remember what it's seen, and in exchange it turns hundreds of millions of comparisons into 30,000. Trace 1, 3, 1, insert 1, took new, insert 3, new, insert 1, pushed already in the set, so we return true. Done in 3 steps. There's one more approach worth knowing. Sort the array, then any duplicates sit next to each other. So you check neighbors, that's in log and time, but uses no extra memory. Handy when memory is tight. So the hash set is on time and on space. Sorting is in log and time but constant space. And the brute force is in squared, fine for tiny inputs, but don't ship it. The Rust details, hash set from the standard collections, insert returning a bool you can branch on directly, and iterating by reference so we don't copy the data. Recap, walk the array once, insert each value into a hash set, and if insert says it was already there, you've got a duplicate on instead of on squared. Quick one, if these help you, the wallet's on screen and there's a Ko-Fi link in the description. Every tip funds the next one. The full Rust code is in the description. If this helped, hit like and subscribe. A new coding challenge every day. See you in the next one.